Yo, Nightcare, how's it going? And Muerte. Muerte? Muerte? Muerte. I have terrible pronunciation. Yo, Stooginator. Hello there. Hello. How goes it? All right, let's get physical. Muerte. 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 Or muerte? Muerte? Alrighty, let's begin. Does that mean death? Yeah, it sounded familiar. Death or murder or something. Where's the cat? The cats are outside at the moment. So they are not present right now. Alright, let's start where we left off last time. Last time... Oh god, last time we were doing a thing. That's right. Also, you know what? I'm sick of that frickin'... Let's go texture streaming pool. Where is streaming pool? Texture... This is your intro videos made in your... You mean the, this one... this one here? Or the, you know, stream starting one? How can I take a streaming pool over? budget. Yeah. Why does it need... I guess because, yeah, the whole landscape's loaded at once, so it's an 8K texture thing. Surely that's not that fucking... yeah, let me just go to... Project Ini. Default editor, Ini. Is that the one? What a fucking nightmare. I don't think so. Default engine. That looks better. Control F. Texture streaming. Streaming? Nope. Where the fuck is it? Is it in default editor? That's in like... What about pool? Oh my god. Where the fuck is it? Right, default engine. Well, I mean, the main thing is, how do I get the fucking landscape to just, like, stop referencing that texture? UE5 imported height map. Texture. Streaming pool over budget. So why can't it fucking... Why can't it stream the height map texture? You tried NVIDIA DLSS plugin? I haven't. I don't do much gaming anymore. But you mean for Unreal? I also haven't. Streaming pool size. Yeah, but I just want to know why it isn't streaming pool size. Yeah. Well, yeah, I just want to know why it has the whole texture loaded. I mean, I guess it makes sense because it's the landscape. But when I go like new, import type, yeah, blah, blah, blah. It's obviously got the height map. So I guess it has to have it loaded in order to construct the landscape, because the landscape's so big ass. And I guess in the actual game, you would unload chunks, you know, components of the landscape. So yeah, I don't know. Swimming pool size, 40,000. Let me chuck that in the editor. What is it? Default editor ini? Or is it default engine? Where we can then do... in renderer settings, r dot streaming pool size 40,000. Let me just go pool. Pools. Oh, there's the virtual texture pool stuff, but this isn't a virtual texture, so yeah. Is that definitely the command? I mean, if you do it every time, it's probably it. When you try that down. Right, gotcha. Yeah, I do like, you know, upscalers and frame generation stuff as like an icing on the cake. Obviously, you don't want to be relying on that. How big is the landscape texture? You son of a bitch. Stop fucking... What is it? R dot texture... R dot pool? Maybe I just pool. R dot... blah, blah, blah. Render target pool. R dot streaming dot pool size. Current value 1,000. All right. Yeah, fuck it. 4,000. I've got. Right. Okay. I think because we were setting it to 40,000. Then I got a bit. So it is streaming dot pool size. Yeah, I'll save that. If that doesn't crash anything, cool. Okay. There we go. Yeah, I think we added an extra 0. All right, let's begin the bullshit. So, first of all, our wind simulation. Let's just do... well, let's just get the wind. The debug wind. Not PrismaticaDev, P, WSDF, atmosphere, render target. That's going into here. We don't want to add one there. We actually want to do this. Then we want to divide it by the maximum length of our wind, 100 miles per hour, or 100 fucking whatevers per hour. Then we add 1, and then let's append the temperature. What's our max temperature? Fuck, I don't know. 50 or some shit. I mean, our temperature can go negative, so whatever. I'll just do 30. Apparently for NVIDIA, the best solution to optimize a game is to let final render by an AI who recreates your image in real time. Yeah. Doing like, what's it called? What is it? Neural rendering? Pretty wild. Alright, here's our wind. Wind. On a very large scale. So, we need to... Let me also just change the wind down to like 10 or some shit. I don't know. What's our default wind? Yeah, you know what? 10's fine. Divide by 10, shift it up, remap it, do the thing, whatever. So, we have our atmosphere doodad. I had to think about how to do this shit. And my idea was we do a dot product. This is the current value we want to add to it. I think I should be getting these by a copy, because we're going to then get... Or we're going to add a value to it and then reset it. Rather than operate on it directly, because it's a 2D vector. Kind of dumb. Smack that in, smack that in, smack that in. Then we need to... So the wind travel this step. Oh, my mouse is being shit as well. Yo, Jed, how's it going? Nice stream earlier. I was watching. I was glurking. I was just lurking in the background. Good. Alright, so we've got the cell size. We also have the dot product. Someone just agreed to buy my Syndicate stand. Hell yeah! Rich AF. Here comes the money. Da money. Wind travel, break the thing, get the 3 points that we may be influencing. Although I guess if we're going... Maybe if we're going straight up, we'd want to do this one and the side ones based on some shit. Because what I was thinking is we can get the wind travel. This step. We can normalize it for now. Just whatever. And then dot against the direction... This is tough. Oh no, well I guess we know which direction they're all going in. Yeah, maybe I don't just want to do that. Because I'm thinking, right? I'm thinking. I think, therefore I am. If we... Actually, I made a grid here. There we go. If we... Let's say this is where we are. This is the cell that we're operating on. And it's moving... here. And it's moving in this direction. I guess, yeah, we want to affect these cells. And I guess, yeah, if it is moving straight up, aside from doing diffusion, you know, there isn't really a need to fuck with anything else. So maybe it's fine the way it is. So what I was thinking is, yeah, we can get the dot product. And the dot product... and something. And something happens. I don't fucking know. What was I thinking again? We get the dot product. If it's 100 units going up, then it reaches this. Which means we get 100% of this, chuck it in there. If it's going this way, we take 100% of it, chuck it in there. If it's going this way at 100 units, we only end up with 0.7 units being distributed. But then we would need to put some of it into these ons. Some of that value. Which, like, one idea I had, which could be smart, is to literally just do this one, chuck it up here, you know, and then get the distance from this point to the origins of all the squares in question. And then split it between them that way. Maybe not even between itself, because we know how much it keeps based on the length of it. Well, it would be the length... the fucking radial length, because if it's length up this way, then it's 100 units. If it's 100 units this way, it needs to be 141 units. So, yeah. But I think the distance check to determine the... that means if it goes 140-something units, it would go 100% to here. And also, we can't let the wind go faster than 100 units in one step. Which, like, what's a really fast wind? What's like a hurricane wind speed? Category 5 is 157 miles per hour, which would be... Let's go... Oh, meters per second. To be classified as a hurricane, a tropical cyclone must have sustained winds of at least 33 meters per second. Okay. Okay. Should be fine. Sample Grid 2D by default is calculating average of 4 cells, right? Yeah, but this is on the CPU that we're running the simulation, and then we're sending it to a render target to be accessed in the shaders and stuff. So our actual simulation is in CPU land. And so obviously we'll have to write, you know, we'll have to linear interpolate when we are sampling you know, what's the wind, like for gameplay reasons, what's the wind position at this point. But, yeah. But I'm just trying to think, because usually in a GPU fluid sim, you get, if we're operating on this pixel, we can only then set the value of this pixel. We can't be like, oh, let's take this pixel and then add something, you know, to this pixel, and then when we operate on this pixel, we'll also add something to the other pixels and whatnot. So on the CPU, so what you would normally do on a GPU fluid sim is you would do a kernel blur. So you'd essentially get the average of all the surrounding, you know, sample around it, which would give you the average surrounding speed, and then you would backtrack from there, and then use that to pull, you're like pulling the wind values into this one. Whereas because we're on a CPU and we have access to all of them easily, we can just be like, oh yeah, get this one, get the one that it's going to flow into, and let's build up, you know, a buffer there. We only have to operate on 3 adjacent cells per dude. So I figured it would just be more optimal that way. But yeah, I think if we... So we know the 3... Well, okay, so the only problem is if we... Let's say we go up here, right? And we do this. This is our wind movement in this step. And then we do a distance check. This one's really close, but there's some amount of these two. And because we're only doing, like, you know, the 3, it means that if this changed by 1 degree, all of a sudden these ones would get... So we get, like... We'd get favoring and shit. We'd get some bias. So I think it does have to be dot product based. So this is the cell up here. We do a dot product. So let's say this is our vector. So it's moved this much this frame. And let's say that's... Well, let's say this is 100 units of movement. We need to know... Like, essentially, this one here doesn't need to receive any of it. I guess we can just do, like... dot product... Absolute of the dot product, subtract 0.5, multiply by 2. To create a... Like... Essentially 3 sections that have some overlap. So if it's going purely north, then it will only send values into here. But then as it starts to go slightly this way, it will begin sending values into here, to this cell and this cell, and then as it reaches the very middle here, it'll only be going into this one, because this one would have run out. So maybe there needs to be some overlap between them, so that when we go... Because, like, when we go diagonally... We kind of want it to bleed into these ones a little bit. So we could just figure out some fucking value. I don't know. So are you doing weather on CPU? Because it's affected by gameplay and affects gameplay. So, like for example, the snowfall or the wind values. All of that needs to be, like, readily accessible for, like, heaps of things. I could do, like, GPU talkback but it's also kind of harder to control on the GPU. So I've just settled on doing it in the CPU, but doing it over the course of multiple frames, and then updating the render target, you know. It's also easier to just, like, kind of connect them all together if it's on the CPU. Like, for example, the wind. Let's say clouds form. Wind carries the clouds. Clouds hit the mountain. It rains, but it's really cold, so it snows instead. And then the snow builds up in this area. And then when we trek from here all the way over the mountains, we get to this point, it's snowy, you know? And, like, that's happened off screen. But if there were, like, NPCs in this area, you know, being virtually simulated, they would be cold, and they would be, you know, they'd probably have a campfire by the time you got there. They'd be wearing warm clothes. They'd be seeking shelter. All that kind of stuff. So it's like, yeah, we're dealing with 14,000 cells, like weather cells or simulation cells. But that could be over the course of, I don't know, some bigger time. GG, watch for a while, still have no idea what the game part of your game is like. Is it a sandbox thing? Yes. Yeah. A sandbox or a world simulation. Fantasy world simulation. Or an adventure simulator. There's a lot of the gameplay prototypes on my YouTube channel. Like the old devlog series, which was me just kind of learning Unreal and dicking around and getting in way over my head. But now I'm a bit more... I think in some ways, I'm way smarter, and in other ways, I'm even more delusional and, you know, a bit psychotic. But... yeah, but nothing. That's all. Something wrong with me. So let's do this. We get the dot with the up. So is this always the... yeah, because we're getting the X and the Y. This is our uppy down. Our sidey side. So we can get the... wind travel dot product absolute. So we go, wind travel, normalize. That's a pure function, isn't it? I should probably get the normalized version. Or maybe I don't even need to normalize it. Scope creep, the game, the movie. Exactly. Well, you know what I like to say? Is that technically it's not scope creep, because it was all in the initial scope. You know what I mean? Scope creep is like when you're like, oh, I'm gonna make like a slot machine game. But then halfway through you're like, oh, what if this slot machine had a weather simulation in it? That's scope creep. Exactly. I could do a dot against 1, 1, because that would then have a length of some value. Because that would be diagonal, right? Going to decide to simulate the terrain erosion as well? No, that's a bit extreme, I think. Even for me. I think as soon as we start getting into, like, changing the actual geometry of the terrain, I'm just like, you know. Question about mutable plugin. If you know any, can we add any scaling meshes dynamically in runtime without first defining in the graph, or should all possible meshes first be in the graph? I'm really not sure. I don't know if you have to define like one of the mutable, you know, asset types. There should, I mean, if you're just doing scaly mesh merging, you can, there's a function called merge meshes, merge meshes, params make skeleton meshes to merge, bam. So I can be like, oh, merge the helmet and the helmet and the armor and the character. You just chuck them all in there. You can tell it to like kind of UDIM it. Some other shit what the skeleton needs to be. And use that one. That's the kind of old raw dog version, which is still in, I think it's in the engine plugins. But yeah, I think, yeah, so I think you do have to set them all up in advance to be used with the plugin. But you can just like, you can compile the list of it dynamically. So like, oh, I opened a chest, I found this funny looking helmet, which has a reference to that data table with all the, you know, the assets and whatnot. The mutable, this helmet type. And then use that to merge the new character. But I think it just needs that data asset for, like, reasons. What is... So if I didn't normalize that, that's what I want to know. And this is diagonal normalized. So a diagonal value of 1, 1, which would be 100 meters that way. What do we get in all our little bits and bobs? 0707 here. So then how do I... Well, no, because it's diagonal. OBS, why? I literally just fucking updated OBS, and now it's just cutting out and shit. My other idea was if I got... So if I got this, it's straight up, but then, you know, to the side, or, you know, with up. That would be a dot of 1. This would be a dot of 0. But then as soon as it is to the side, or I'll just say 1, 1, normalize 2D. Does, yeah, no, that does. As soon as it's going diagonal, we get 0.707, because that's saying, hey, we're 0.707 of the way from here to here. So if I divided that by 2, that wouldn't really be... Well... So what if I get these? 1 minus them. Or absolute. 1... there is no 1 minus, is there? I swear there used to be one. 1 minus. And then this one. 1 minus, and then multiply them together. So that, and this is diagonal. I see. Without the 1 minus. You get 0.5. Right, because 0.707 multiplied by 0.707 is 0.5. That's handy to know. Ugh, this is just... If it's going up, I only want it to go here. You know what? Let's just fuck with it. Let's just be like, yeah, get this, do the thing, whatever. Get the... normalized. Because if that is dotted against... That's the thing, though, is that the diagonal isn't... Diagonal isn't 0.5 in dot product land. Because it's circular. It goes like this. So this is 0.707 when it's at 45 degrees. You know? Do I just want to get the angle and, like, fucking map a linear schmoodad to it? No, that doesn't make sense. None of this makes sense. Let's just fucking go in here. Let's just get something happening. It's fine. Let's just get the dot. Absolute. Well, we can get the absolute of the normalized vector. So we just know, you know, are we uppity or downity or whatever. Get the dot, subtract 0.5, multiply by 2. saturate that. I guess clamp. Whatever. So we're going to get this. We're going to add some fraction of our wind travel this step. Based on... Well, if it's going diagonal, and we get the 2 dots of the sideways ones, let's do this down here. And then sideways is there you go. Okay. If we get the max of... Oh, would that even... No, I think we want to get the... No, it's just sideways. Yeah, okay. So we want to get the max result here. Or the... Yeah, the higher value from the 2 sideways ones. And then... That will be... This. There. I mean, that would kind of do it, though, right? For the diagonal. If we get the max... Because if that's 1... Well, that's 1. No, but we still have to do the dot. Something. I don't know. Let's just get some fucking wind moving around. I don't care. We'll get the up, down. We get the sideways. We get the diagonal. You go in there. You go in there, you go in there, and then we need to set the thinger. I guess this is going to come up and around. Reroute. We're going to get our wind meters per second array. We're going to set array element. This one. And then this one. And then this one. 1, 2, 3. Target arrays, wind meters per second. Yep. Oops. Then you go into there. There. And that should be fine. Well, what's the... I don't know. Would not be easy to work in radians. I mean... Maybe? Maybe? Probably? Diagonal distribution of of grid-based simulation. Diagonal and orthogonal neighbors in grid-based simulations. Buffins stick after 200 years. Rectangular grids are frequently used in spatial simulations, often with nearest neighbor interactions, but each cell has a diagonal as well as an orthogonal nearest neighbor. Here, a simple abstract model of weed spread demonstrates that the relative strength of diagonal and orthogonal interactions affect simulation outcomes by determining the threshold conditions required for spread from isolated and aggregated colonized cells. The relative strength of diagonal and orthogonal interactions implicitly represents the range of interaction processes. The von Neumann neighborhood, which has no diagonal interactions, represents processes with near or negligible range, such as contact processes, increasing the relative strength of diagonal interactions, blah, 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 blah. Spatial simulations, spatial lattice, rectangular grid with square cells, coupled map lattices, population-based models, interacting particle systems for individual-based Many such simulations have been called cellular automata. True. Game of life. Choosing large enough cell dimensions to restrict interactions to nearest neighbors maximizes the speed and simplicity. Okay. Demonstrate the relative strength of diagonal and orthogonal interactions can sustainably affect the result. Introduce a simple, long-standing but neglected method for calculating orthogonal and diagonal interactions. Propose and investigate an alternative arbitrary solution intended to approximate the properties of a nearest neighbor in a hexagonal grid. Demonstrate the abstract simple example, blah, 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 blah. Alright, well, what about you fucking show me the paper? Anyway, let's just do it. Wind travel this step. We get the current wind meters per second. Do the thing. Blah, 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 blah. So let's just do a function in our thing called debug step forward. Debug step forward simulation times 100. Or times 10. Times 10. So we do a for loop. 0 to 9. This doesn't really matter. Loop body is going to get the length. Actually, I can just get the length, right? Just get length of that. And do a for, well, I can just do for each, right? For each loop. Update cell. Index this one. Delta 1 second. Yeah, I'll just say 1 second. So that will then update cell. And then on completion of this, we... well, we need to ask its fella. Just get actor of class. Why not? The atmosphere. Debug drawer. Whatever. Let's just say update all values at coords, or refresh, or initial. The fuck was the thing called again? What's the damn function? Pull data from coords. Oh, every coord. Didn't I have a function that could pull all coords data, which will then create a big coords list, and then so dumb, but it's kind of how it's designed. So pull all coords data. Cool. And then that needs to be called in editor. Oh, you know what? I could just do this in, what's it called? Could just do this on tick. Why not? On tick, loop over every fucking thing, update the cell, and then on completion of that, do this. And then the delta is delta world seconds. Although it's not really supposed to be done like... we can just see if shit happens, right? Simulate. Alright, what's gonna happen? Are we gonna get out of bounds? But it's really not happy. Why are you not... oh, there's something. Alright, maybe I shouldn't do all 14,000 at once. Hello, engine? Can you not do that? Also, I need to, let me make another coffee as well. Hello. Oh, look at all these nice, juicy errors. Access temperature of length 0. That doesn't make sense. Did we not? Let's just go to our atmosphere, fella. Where are you? Here. Calculate initial data. Okay, so we are going to let's do a custom event. Update thing. Bam. And so when we update thing, we're going to update all cells. Delta 1 second. On begin play, set timer. Timer, function name. Update. Thing. Time 1 second, looping. Cool, so then we're going to go through all of our stuff and do update cell. Get after class, pull all cohorts data, and then it's going to do its thing. Now we do need to make sure. When we go initial data, the data handler. Data handler actor. No, that's the data handler. Where's here? Oh, that's the debug fella. You fucking whatever. This one's not real. Here we are. Jesus. Init data field. Hello. Which is just saying calculate initial data. Get active class, do the manager. In here, calculate initial data. Does get terrain, does get the manager, because it does this. And then that's generating a kind of random noise. If I go to the... Oh, why has that still got its fucking slate 50 billion array length thing? Right, let me just go into that. No, not that one. Go to terrain. No, not data field. Terrain. Here we go. These do not want to be exposed. I mean, I do want them to be, but I'll say don't. You know what else would be easier? Is to just fucking get this whole volume and just shrink it down. Just shrink that MF down. Cell size still 100, but then... what? That's already... How do I change the... Is it the resolution? No, grid array length, on the corner. Oh no, it was this one, the bounds. Yeah. Let's go like just 1,000. 5,000. Let's just do this for now. So it's just a 10 by 10. So when we get errors and shit, it is way more good. Maybe a bit bigger. Maybe 2,000. Yeah, cool. Alright, let's go. Compute grid resolution from bounds. Draw the debug grid. Oh, reinitialize manager. Compute, draw debug grid. Where's our debug? Oh, they're all underneath the thing. Let me just go into draw debug grid. Let's do you from 100,000 down to negative 100,000. Yellow. Alright. Draw debug grid. Big. Big boy. Alright, then if we go to our... So I've reinitialized it, done that. That means that the terrain needs to calculate its initial data, which it does with like 1 billion line traces, or sphere traces in our case, which we don't actually need right now. And then we go to the, I guess the water one, doesn't really matter either. Let's go to the atmosphere, calculate your initial data. Hello? Well, why are you not... Ah, right, it needs to pull all coords data. No? It's because atmosphere isn't initialized? Why is this? Ah, because the fucking render target size didn't update? Hmm. One two oh, 120. Because now if we go to this, it knows that it's 40 by 40. It knows where the top left corner is. It's been reinitialized, but why isn't it... 90s cup textures, true. Right, I hadn't reinitialized the handler. So then if I pull all the coords data, it is doing nothing. Fantastic. It's exactly what I wanted. Just kidding, I want to die. Debug drawer. So you've been reinitialized. We've cleared the render targets. Let's go to the atmosphere, calculate initial data. Now why can we not... Okay, now it is working. So we've now pulled the data. I also might just make this noisier to begin with. Atmosphere. Initial data. I don't know, way smaller. Okay, nice and noisy. So these are our wind values in here. I wonder why it looks so much bigger though. Isn't it supposed to only be... Right, I wasn't doing something smart. I was doing something dumb. I remember. Right. Remember how I was like hard coding these values? Kill myself. So this is our what? Top left corner. And why is simulation size? Oh no, calculate that. Yeah, 400,000. By 400,000. Cool. Rapid for initialize compose all by one button. Yeah, I think that's what I will do at some point when I'm less silly. But you know how it goes. It's more so if I only have to do one of them, I can just do one of them without needing to like dick with everything. On new simulation cycle, we put that into the wind cache. And the fucking... You know, let's not even worry about fucking temperature. Fuck you. And then the wind meters per second, and then we reset it to its defaults. Which is terrible, but... whatever. This should be on new simulation cycle start. Rather than at the end. Let me... Oh, this is a fella. Alright, new sim cycle start. So yeah, this is an absolute mess, but let's just see what happens. We should see something happening, right? We should get some kind of unfuckery. We also want to do this by the... So the wind travel this step. Will clouds be part of the atmosphere, SF? Maybe. I might break it down into, you know, smaller doodad bits. What does it simulate? Is anything happening? I mean, we're getting hitches, so something must be happening, right? Oh. Hello. Wind meters per second, length of 0. Right. Why? Why is it length of 0? Atmosphere, calculate initial data. So that definitely has all of its shit. Calculate initial data, blah blah blah, loop through the grid array length, which is some big ass value. And that should go through all of them. And then add to the wind meters per second. That should have been cleared, yep. And then temperature, let's not even fuck with. So wait, what's actually trying to access those? Oh, let me just run it again. Which... But who's actually... In the debug drawer, pull data from coords. You're getting an atmosphere, dude. and you're trying to do wind meters per second, you're trying to pull that and add that to the thing. Let's ignore you for now. You can just die. I was loading the wrong data asset instance the entire time. Fuck. That's rough. That is rough as guts. So wind meters per second. Why is that a value of 0? Oh, is that only the initial one, maybe? Let's just do a really shit race condition unfucker. Yeah, whatever. Right, so now we should get less. Less errors. No, we still get them. Wind meters per second, length of 0. Pull data from cohorts. When we do this. Oh, is this getting done on... No. This is pull data from cohorts. Let me just do... Cohorts, pull data from cohorts in our... atmosphere, dude. Get actor of class, the thing. We have found it. Very good. Can I see... Okay, so... all of its shit is empty. But is it actually empty? Or is it just telling me it's empty? Why would they be empty? Are its values not carrying over from when it's in editor? Let me just real quick, let's just run initial data on begin play. Yeah, like, should these should... Maybe they're not instance editable. If they're not instance editable, maybe they just clear themselves on begin play. Alright, so now we have big wind and wind cache, so whatever. So it should not throw errors now. Driver global wind params for foliage and stuff. Yeah, but it's more so for like gameplay related stuff as well. Like temperature, rainfall, snow coverage. Update cell delta 1. Let's just fucking delta these nuts. Let's do this first. Let's just see, you know. Okay, so we have a value. This is the wind travel this step. Delta should be 1. Yep. You are then going... Where's step? Next node. So we're then setting on this one, the big empty one, which should be... These should all be... Yeah, they're all 0, 0, 0s. Then we're saying get this value, negative 1, 9, blah, 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 and 2. This one's 0, 0, 0, and this one's all... Oh, no, it's just because we haven't gotten to that yet. So I go forward, forward. Then we should see these, yeah, because now they've been computed. 7 point... What is that one even... That's coming from here. Right, that one's a bit fucky, but... Right, that should be normalized. But, I mean, either way, let me just... I mean, fuck it. We know the outcome anyway. Fuck it. Save the square root. So that is all getting done. And those values are getting set. And then, yeah, when we get them... Because we're getting copies of it, which is fine. And then we should be able to set them properly, which we can... Let's just... not play again. Let's just... Fuck off. Hit sim again. And we'll just hit resume, 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 resume. Then get our... Well, our wind cache is, again, just all our initial values, but we want to get the wind meters per second, fella. And, yeah, the first few have been... Okay, yeah, so things are actually propagating and populating. So then by the end of it, here, pull all cohorts data, we should be able to see... No, wrong button. Mark, how goes the procrastination? It goes very well, thank you. It goes very well. So after that's done, then we go pull all cohorts data on our atmosphere debug drawer.c. Our wind meters per second should have all of our funky ass values. Yeah, heaps of new shit, whatever. And then when this happens, step in. Did you not want to... Can you not go in? Pull all cohorts data. We then get the grid array length. And then populate our cohorts. Then pull data from cohorts for all of those cohorts. So this should be working. And this is what, only a 40 by 40 thinger? Let me just, now that it's a bit less fucky, let's just do every, like, 10th of a second. Or we say the delta is that, but we speed it up 0.1, so 10 times a second. The delta's 1 second. So we're 10x fast forward. Kill the breakpoint. Resume. Are we getting stuff? I literally cannot tell. Something's happening, but... Dunno. I can't tell. Right, let's just move to a really dumb propagation. Let's just do an XY don't even fucking care about the diagonals, right? Let's just not even... You can just fuck off. You don't even exist. Oh, do I need to be, No. Is it, fuck. If our thing is like this, then X is... Oh, is it because X is side to side? No, I already knew that. X is side to side. Sideways, this one, we go plus X direction. Or the sign of the X direction. We swoop it over. Let's just get the wind travel this step. Divide it by... Oh. Divide by 3. And let's just... We'll blur it, you know? Blur it up, down, and then we probably also want to just keep some in the original. Let's just say original XY. Well, we already have the index, so let's just grab you, smack you in there. Get this same. This is so fucking messy. Let's just get... No, get... from this guy. No, we get from... Alright, that's the current one. This should be 0. Yeah, no, yeah, we want to get from here. Get a copy. And then add this shit here. We don't give a fuck. So we're literally just going to get the up and the down and this one and just spread it between it. And that's all. Let's also just get this into there. And we don't care about... Well, the delta... The delta's still just 1, so who cares? Who cares? Simulate. I saw something move. Well, we're losing blue values, but that's fine. I can't tell. Is it just not... like, what's happening? Bruh. Okay, let's just... I want to have some persistent deformation using a render target array. Is that feasible, or should I somehow cache it to an RVT? What kind of deformation? Do you mean for, like, a character moving all the time with, like, footsteps and stuff? Let's just see if this is actually, like, you know, doing the thing. No, okay, so it's not even, like, pulling the data properly. Because we're just saying set array element to this specific value on our wind meters per second, dude. In our event graph, when we do new simulation cycle start, wind meter per second, which is definitely long, update all the cells, pull all coords. Atmosphere, pull all coords data. Let's just make sure this is getting... Well, then this should be... Well, that's in the base class. You know, atmosphere debug drawer. Pull data from coords, get actor of class. Atmosphere. Gather wind meters per second. Coords, values, this frame, RG. From here, send data to Niagara. That does this. Oh, is it because of the masks? No, that wouldn't be it. Yeah, I'm not really sure about render target arrays. I haven't used them myself. Yeah, I don't know if it's like render target tiled or if it's like stacked render targets like a texture 2D array where you can just like sample a texture stack rather than doing multiple texture samples and that kind of thing. Let me get this. Fuck is it doing? Why is it? Why is it only length of 1? Pull data from coords. That should be a big array of stuff. Okay, coords is like a big list of, yeah, 1,600 things. Pull data from coords. Coords is that. Yep. For each loop, big thing. Get actor a class for each loop. Values this frame. Step into the next. Oh, fuck you. Yeah. We get it. Macro these nuts. Now that has 2. Okay, so that should go over the whole thing, and then... And then do the whole thing again, which it is doing, so... Why is it shitting everywhere? Where's this frame? Yeah, right, so that should be a small number. Initially. So then why are you not getting updated when I hit simulate? No, fuck you. I'm literally saying, like, just set it as like a, what's it called? As a value, you know? If I said do this, pull all coords data, blah, 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 pull data from coords, and then it tells us, not this one, but the atmosphere debug drawer. Well, yeah, okay. Clear the RTs. We go into this guy. Values this frame, masks this frame, whatever, whatever. Let's just set this to be, you know, red. You will be red. And I hit simulate, and when it gets updated, it should. Right, no, because it's masking. No, that should. What the fuck are you doing? Atmosphere debug drawer. Is this maybe just not getting... Like, is this all getting fucked up? Is it maybe using the wrong default values or some shit? Like... No. How... What are you? Send data to Niagara. Get the grid 2D handler system. Get all the shit. Send it through. Clear that MF. Hit play and said, yeah, it's not a bad idea, but now we're just going to be flying. But it's still not changing anything. Let me just, like, go into data handler, fucking whatever. When we initialize handler, let's just call that on begin play. Just in case it doesn't. You know. Just in case. Just in case it doesn't carry over. Well, I mean, it's drawing something to the... What the fuck is it doing? Did I just fucking... When we were dicking around with... the system, did I... have it doing... some really dumb shit? No. Well, it obviously works when we do, you know, this initial data and then pull all the coords data. Oh, is the fucking... Is this not... Right, no, because we're... in here, we were just telling it to do a hard-coded value for a second. So that's now our thinger. So if I do this... Yeah, it's like it just forgets how to fucking function. And then why do we get these random bits in the blue channel? That's like from a that's from a different thing, but I don't know what's calling that. What was it that was doing this? Every doodad? What's a goal here? We're just doing like a wind simulation across the whole world. But it's hard. Can I do a like a sample? How do I do a fucking UVs multiplied by 40 C floor divide by 40. Chuck that in there. I just want to see this as a grid. Yeah, this is Unreal Engine. Yeah. Is that the right? No, that should be seal? Oh no, it should be round, right? I don't fucking remember. No, that does a half offset. I'm pretty sure it's floor, or maybe it's... something. Oh god, I don't know. I don't know shit. Yeah, no, it is 39. So I think what's happening is something is when I do the debug step forward, something is doing something somewhere. That is correct. That is so true right now. Okay, so when I step it forward, it is doing a thing and writing it again. I would just need to plug these shitty-ass values back in to get some fucking resemblance. I get 1, 2, 3. Who cares? Whatever. Oh. Right, so that's doing a thing. Maybe I'll just step it forward 1. And that's just with our shitty, dodgy thing. Calculate initial... And then here... Step forward times 1. Why do they all go... to shit? And are you... RG divide 10, add 1, divide 2. Okay, so that is posneg. If it was 19... Oh, sorry. Yeah, I think I know what you mean. Oh, yeah, you're right. Yeah, I suppose. Oh, no, I bypassed it. It is just doing 1 step. Although now it isn't doing this. That should be getting done. Yeah. So there were some issues and some issues not there. I don't fucking know. So why is this happening? Why are we getting this weird-ass diagonal? I mean, look, we can see it doing something, right? That's a start. If I hit play. Well, let's just calculate initial. Pull the thing, do this. I can't tell, are these moving at all? And I'm 90% sure they're not. I think it's just optical illusion. Something else is accessing the drawer on tick and overriding. Like, see how it's like, drawing to this every frame? Because there was something I was doing that was like, oh yeah, let's like draw to a random value every frame, like a random blue value, without affecting the RG value. But where was that? Where was that I was fucking doing that? You know? It was right here. I'm a fucking idiot. Spastic. Okay. So now, yeah, okay, now it actually... Because the whole point of the simulation, or the debug drawers, is that they pull the data, that they're in charge, rather than things telling them when to update. Okay, so we have shitty wind simulation kind of thing. Look, it's doing something better than nothing. Let's go back to our atmosphere thing. Update cell. Let's just... Let's figure out what we are doing. Let's kill that. Let's just clear all this shit. This is all dumb. This is all stupid. This is all stupid shit. That's dumb. That's dumb. This is... Well, technically, no, we do want it to... Anyway. Let's do a sequence here. So we set this one. Then we need to set to itself as well. Because look, wind is never going to move backwards. And I don't think we really need to do diffusion. Very much. I don't know. I guess we'll see. Alright, wind cache. We get the thing. I mean, the other way I could do this is to do a kernel, but this makes more sense to me from a CPU side of things, where each cell says, "Oh yeah, I'm gonna add some values to my surrounding cells in this direction only, not all 8 of them." So the first thing we need to decide is how much of the wind is getting sent from this cell to neighboring cells of any, you know, any direction. Which is basically, if it moves the cell width, so the cell size from here up to there in a cardinal direction, then 100% of the wind, minus any damping value or whatever, would get moved up to that one, you know? If it was if it moved 50 meters in the update, we would send half of it to this one and keep half in here. So I guess the same would go for, if we go diagonal and we move 141 units in one update, then we send 100% of this and distribute it some fucking ratio between them. So that is determined by, I guess it's the maximum dot product of the normalized vector between the two cardinal directions. Right? Because if we... Well, no, because then the fucking... Yeah, no, that makes sense. Let me go to the bathroom real quick. Alright, I'm back. Needs to think off to the bogger. Disgusting. I would never do such a thing. Okay, so first, let's just determine how much is leaving the cell. The cell distribution ratio. Hashtag ratio. I could do this with the wind travel. I could just dot it directly with, you know, up or down. Uppity or downity. Doing that way, I was thinking along the lines of a flow map style things. Well, yeah, we're essentially creating a flow map in real time. Based on, like, you know, the terrain elevation and that kind of thing. Because the reason I want to do it that way is that if people want to use this system on a procedural world, then it can just work, you know? It doesn't have to pre-compute. Well, I mean, it still pre-computes some stuff, but you don't have to, like, hand author, oh, this is where all the wind goes in the world kind of thing. It should just be able to figure itself out. And, you know, essentially put different biomes in believable places. Like, oh, this big valley here, you know, might become like a big rainforest because, you know, because it's like hot, but it's also like on the leeward side of mountains, so it would get a lot of rain, and therefore, and also all of the water runoff from these mountains would, you know, end up in here, so it would be really well moisturized. And that should just naturally occur, you know. Let's get the abs of that. What's abs max? Maximum absolute value of the vectors component. Ah, right, of both of them. Oh, that's... Yeah. Alright, so let's just do this. So, if this was diagonal, if it was completely diagonal, we would get 0.707 of the fucking distance. So, if we get the cell size from the manager, cell size world space, so if it's moving if it is moving directly up or directly sideways, then we want to move 100% of the thing. Well, if it was 100 units of distance, then we'd want to move 100. So that would be this divided by this, or the other way around. Oh, well, no, we need the wind travel this step. Well, no, we fuck! The wind travel... My brain. My dummy-ass brain. I mean, we can just get the length of this, right? Let's just get the fucking length. Wind travel this step. which is the delta, the wind cache, wind travel this step. We get the length, we divide it by the cell size. But that should be the cell size. And then factoring in the diagonalness. The diagonality. So if this is 100 units, then some of it... Well, does some of it stay here? Or does it just get distributed into these ones? That's where this gets real confusing. Because, like, if this moves 141 units, exactly diagonal, it kind of seems a bit dumb. You know, like, if it goes diagonal here, shouldn't it kind of spread out? I mean, that's the kind of fucky... Let's do a bit of Googling. Dealing with diagonals in grid simulations. Research gate. Yeah, because it's fucking gating me because I need to pay for the damn paper. Cell simulation diagonals. Wind simulation diagonal cells? Moving in a given direction doesn't care which. Neither should you. You mean... Well, no, like, cause we're adding part of this to the other cells, right? Should matter if it's diagonal or not. Moving in a given direction. It doesn't care which. But it's just like, if it moves diagonally... Well, like, for example, right? If it moves straight up, I don't want this to affect this value here. I only want it to add its value, or part of its value, to this one. If it moves diagonal... If it moves diagonal, then the length is 141. Well, okay, let's say... How do I take cell size divided by cell size divided by this, right? So that means that if it's going straight up, it's 100 units. If it's going diagonal, or as it becomes more diagonal, it goes to 0.707, which 1 divided by 0.707 is 140, well, 1.41. So that then gives us the distance needed to travel to empty the cell. So then we get the length. And then if it is 100, if it was 100 units, but it was going diagonal, then that would be bigger number, blah, blah, blah. So then it would only empty 0.707 of its thingo. So then we get this. Pardon me. So then this should output our fraction to be removed. Let's just make sure that's a 0 to 1. And then the inverse of this, 1 minus that, should give us the amount to give to the other cells, right? Yo! Acrylic Pixel. Hello, hello, hello. Also, Amethyst, it is going... kind of... It's doing something. How's the computer going? Did you end up finding a cable or testing some stuff? How was the stream? What were you working on, Pixel? I'm currently working on a really silly thing. Right, I'm telling that to set them to 0, because I'm dumb. Orbs, colorful 2B puzzle game. Hell yeah. I love orbs. I love pondering the orbs. You know what? I'll wishlist it. Ooh, that looks... Ooh! I like the shadow casting. What's the method you're using for that? Is it radiance cascades? Looks so dope. Nice! Hell yeah, hell yeah. That's cool. I'm currently doing some silly stuff. And I don't know whether I'm regretting it or not. It's like... Do I really want to do this on the CPU, or... I don't know. It seems... Oh, no. I guess CPU makes way more sense. But what I have done in the past is, like, I've done wind simulations and compute shaders and all that kind of stuff on the GPU. But now I'm just trying to do a more efficient CPU-based one, and it's just... It hurts. It hurts my brain. Oh, good. Have a good night. Or afternoon. Or morning, even. So how am I going to frickin'... I don't know. How on earth? How on earth? Well, okay, so we've got the split of the stuff that goes to the next cells. Then we just have to determine what is the split between the cells, which is a whole other thing. So I guess firstly we can... So we get the length, Oh, yeah. So we can get the wind travel this step. Oh, I need to, I've just realized. We need to divide it by the delta, right? No, we cache the wind value. And then we are... I like pain. Yes, yes. No, the reason I'm doing it on the CPU, is so that all of the data is like directly accessible. And, you know, I'm not going to be doing it. I'm not going to be doing the entire thing in one frame. I'm going to be doing, you know, just iterating all over all of the cells one by one in just a big loop. And then once it's finished, cache all the values and then go back and do it again. I mean, the other thing I could do if I wanted it to be more of a round robin is to actually, once we're 2 lines down, we actually start writing these ones into the cache and to the render target, you know, one by one, so that we don't dump it all into Niagara in one go. That way, yeah, because if we presumption that everything can only ever extend one tile, you know, like nothing's... Because this is like 100 meters per 100 by 100 meters for each cell. We can essentially presume that once we're done, you know, this line and this line, as we're updating these ones, we could start, you know, telling this one that, hey, like, these are, like, the final values. And that way we wouldn't have to dump our... That's actually a good idea. How would that work with the boundaries, though? Because, yeah, currently we're doing really dumb shit just for prototyping, where we, on new simulation cycle start, set this thing as this thing, which is like a fucking nightmare. Because... reasons. Because apparently this doesn't set it by reference. This copies this array into this array, which is stupid. And then we have to clear it and then resize it, and it's like, oh, fucking hell. So I guess if we did a... Presuming that cells only affect neighboring cells... Once we're, like, well clear of it, then we could start writing them into the cache. Potentially. So we just have to figure out how many cells behind do we lag to copy them into the, you know, the cache array, rather than fucking resizing the array in one big go. That could be interesting. It's probably worth dicking with. Anyway, let's go back to our thinger. Oh, so Adam, how's it going? I saw your message. Very swag. I might be wrong, but imagine your 4 square cells. You move the origin cell a certain distance, and now it intersects with all 4 square cells. The amount of wind that you put into neighbors is the amount of area the original cell intersects with that cell, which also means that some of the wind does stay in the origin cell. Yes. Yeah. One of the ways I was thinking of doing it is we just calculate, you know, the distance that it would have moved, and then just get the distance to all of the other cells, including its own one, and then calculate, you know, the distribution ratio that way. The only problem with that is that when we just move up, let's say we moved to like here or something, then it's like, oh, like, yeah, we've got like a decent value here and a decent value there, but we also have some contribution to these ones, which might be very small, but then it also introduces some weird biases where it's like, okay, if this was instead going like 1 degree this way, then it would start putting it into these cells, you know, this kind of quad. And then we kind of move into the territory of like, okay, well, do I just fucking do all 8 cells and calculate the distance like that and just accept that there's going to be some diffusion, you know, so that like wind that is moving in this direction is going to like influence this one to go that way? Which is, I mean, that's kind of how air works, right? Air does create drag behind it to some extent. But this is calculating the wind velocity, kind of. I don't fucking know. I mean, maybe that is just a way that we could do it. We do the original point, we've got these cells around it. We calculate, hey, you just went over to here. And then we calculate, okay, from that point, you know, we go to there, we go to there, we go to there, we go to there, we go to there. We go back to the original, we go to this one, we go to that one. And we just distribute it to all neighboring cells based on that travel distance. Which means no fucking around with dot products, no fucking around with, like, you know. Yeah, I understand how it works, and I've done fluid sims before, but I'm just trying to think of a... Because, like, a lot of fluid sim stuff, you know, you do, like, you do a kernel to get the average, you know, advection, whatever, from its surrounding. And then you backtrack from there, and you pull this value into this one. But I'm just thinking on the CPU, it kind of makes more sense to do a... Like, on GPU, you do it front to back, because you're assessing 1 pixel, and it can't, you know, you can't set a value over here based on this, you know, while this pixel's doing its calculation, because it's all fucking parallelized. But on the CPU, we can do back to front, like backwards to the front. So like a forward simulation. I imagine 2D. I don't know what that's. So this, and then that one. In 2 steps left. Ah, okay. So like this, and then it steps left. The amount of wind, the overlap. Yeah. No, I think I know what you mean. The problem is that the like this value here represents, well, the whole cell, but we're kind of interpolating between them. But I get what you mean. Like, if this moved to here, and it was then like, okay, how much of this square is now overlapping these ones here? You know, what's the area between all of them? I just don't know the math. And, like, I feel like there's a... Yeah. Because, I mean, that does make sense, because, yeah, if it just moved up, then it would just be between these two cells. And if it goes slightly to the left, then, yeah, it will do, like, more in here, tiny bit in here, and most in here, and leave some in here. And then, yeah, if it moves 100 units into this one, then it will still, you know, then that works. So, yeah, I mean, what's the easiest way to calculate the overlaps, though? Maybe we do that. That sounds a lot better than doing an 8, you know, all 8 of them, and doing a distance to the center point. Although I should be able to use the distance to the center point to, like, you know, calculate overlapping area of squares. Okay, I over 2 squares. Size of overlapping area is height equals top minus bottom width. Oh, yeah, true. Yeah, Oh, right, because we know the distance that it's moved to the left and the distance that it's moved up. So maybe that could actually be a lot simpler than I think. Anyway, I need a biscuit real quick. I'll be right back. All right, I'm back. Okay, so overlapping squares. Super duper easy. We need to tell all this to fuck off. And that can... let's do it in absolute. Because it's just XY, right? So we're just going to break this. And for each case... So for our up-down, which is our Y... Well, let's do side to side. Presuming that we're only moving in positive direction. We have our cell width. Where the fuck that went. Hello? Cell width. Whatever. Here. Cell size, world space. So, we can, as we move to this way, how much... So, here's our square. Let's go to yellow, blue land. So, let's say we're starting here. We've got our square. And we're moving in positive directions only, so we're technically moving down this way. We move this square down in this direction. Diagonal. So we've subtracted whatever the movement is. We've subtracted that from ourselves. We've subtracted the inverse of that from this and that in one direction. No, in both directions. Do you know what I mean? We get... Luckily, this is really easy because it's like, it's, squares. They're all the same size and they're not rotated or anything. So... Let's just do X this way. This is Y here. And then this is XY here. I mean, that should be yellow, but whatever. Okay. Yeah, this should work decent. Okay, let me just put this up here. Andre, hello. Hope you're doing well. Alright, so for the X direction, we've moved in X. We need to get the cell size minus the amount we've moved by. That gives us... No, it should be the amount we've moved by minus the big guy. Well... well, the absolute. Shouldn't that equal the same thing, though? Cell size, 100. Let's say we've moved 10 fingers in both directions. So then, cell size minus 10 is 90. And then, that result, well, 10 minus 100 is negative 90. So yeah, we do need to get like the, not the 1 minus of it, but the, you know, this kind of thing. Well, no, it's literally... I forgot it. Fuck. So we need... minus y. And then that multiplied by the x gives us the area for the cell here. Because this length is the movement. This one here. And this one is 100 minus the movement down this way. So then it's the opposite for the y direction, which is the length, subtract the y movement, gives us this length, and then just the x movement for that. Or like, yeah. Whatever. You get it. So x... cell size minus y movement gives us that one. So then cell size minus x movement gives us that long one. And then multiplied by the y. And then for the corner, it is... For the corner, it is... the corner is just this. This times this. X times Y movement. And then the remaining value is this times this. So, well, original, remainder, corner, sideways? Sideways. And uppity, downity. So these are our movement fractions. So then if we just get the originals and the current one. Can I just get current? Yeah, I mean, this should work fine for now, so... So wait, was that uppy, downy? No, this was sidey. I mean, sideways should come first, because it's... Yeah. Let's just... Oh, get that. 1, 2, 3. Current is get the input index. Okay, so we get this. We need to add the wind travel. Well, no, is it the wind travel? Or, no, it's literally just the... from the wind cache. Because we don't want it We don't want to fuck with the delta. So yeah, we need to get the win cache value. So yeah, okay. Sorry, the win cache of the current index. Because this accounts for the delta, right? So then win cache multiplied by this dude. Well, you know what? Let's do that. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. The fuck are you doing, huh? Why does it matter? It changes depending on which way you do it. Whatever. So that, the win cache multiplied by that, added to these. Now, I could totally do this in a loop of 4. But then that would get kind of fucky, so I'd rather just raw dog it. That's the original value. I'm going to add the win cache. Item. 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 Whoops. Let's do you to there. 1. 2. 3. And 4. Look at that delicious spaghetti. Holy shit. You know what, I might just promote this to local. Just so we're not getting it a million times, because I'm pretty sure that would not optimize for that. Win cache this index. Win cache this index get. Get you, smack that in there, fuck off. And that's the win meters per second in the new empty array. Yeah. Alright, let's see if this does anything. So we have this thing. Let's go calculate initial data. Let's debug, clear that, and pull all the coords, and then just step forward. Wow. That got out of hand extremely quickly. I see. Why is it all black now? Now our fucking thing isn't even... Atmosphere debugger. Loop through them all. Add coords this frame. Values this frame. Wind meters per second. Is just at like negative infinity. If I do this now... Wait, what the fuck? Why are you not... Debug atmosphere render target. Eh? Initialize. Is it because this went fucked up? Compute, reinitialize, draw debug grid. There's our grid. Let's get the atmosphere, calculate initial data, atmosphere debug drawer, clear the render target, Why will it not clear the render target? Debug clear RT. Debug clear RT. Get the grid array length. Do all that shit. Set it. Update the values at coords. Bam. Send data to Niagara. Master frame values at coords this frame. Why is it not? What? It's got the world manager. Debug clear render target. It's like the oh, it's like the Niagara system is no 1600, yeah. 1600 thingos. 1600. What's 40 times 40? That's not 1600, is it? No way. It is. It's a big number. Atmosphere cache. Atmosphere render target. Right, so that's because that's a big ass number. Is it just because it can't do it? Is it just broken? Alright, let me just restart. Oh my god, now my fucking audio's fucked up. And now, are you guys getting audio now? Or am I, can you hear me? Okay, good. It's working. Okay, see this? What the fuck is this? We can hear. Okay, good. I'm so glad. I am hashtag so glad. All right, atmosphere, calculate initial data. Step forward simulation. It goes to 0. Calculate initial data. Debug drawer. Pull all data. Initialize clear? Okay, that did clear it. That's good. Pull all cohorts data. The fuck? Okay, well this... Maybe this needs to be... Compute. Reinitialize. Draw debug grid. Atmosphere. Calculate initial data. Debug drawer. Pull all cohorts data. Why is it not getting it? Bruh? I wonder if I can clear the arrays in here. Like, clear? I can do that in Niagara. Fuck, maybe I do want to do that. Cache and target data, RT. Generic simulation stage, number of iterations. Weird thing. Because this is technically running every frame, right? Iteration source, direct set, 1, 1D, element count, 1, new scratch pad. I mean, I could just, you know what, fuck it, I can just do that in the other. I can just do that in here. Don't even need that. You can just fuck off. I don't even think I need to... I think I can just do this in here without that one. Because they're the exact same thing. And then just a new scratch pad called Clear the Things. And then this is the array... well, the vector 4 array. This is the values. Another vector 4 array. This is the masks. And then a vector 2 array, which is our coords. And then we just literally clear, 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 and clear. So then Niagara isn't going to write stuff again. Function go clear is not allowed for stack context usage. Okay, well then don't. Can I not clear the user specified thingos at the end? No, okay. I mean, what I should be doing is... yeah, it should just work. Render target is red and row in the same stages, not allowed, read will be invalid. Ah, okay, so that's why I had to do this. Hello, get in there. Get the fuck in here. There you go. Okay. So yeah, what we want, ideally, is to... whenever we send... pull all coords data, calculate our coords thing, pull data from coords, those are all the coordinates. We then just want it to... pull data from coords, do the thing, send data to Niagara, which then sends it to Niagara. Oh, right, because it's not going to fucking... when it's ticking... it should be doing this, send data to Niagara. Every frame. Which will then set them all to 0, and then it will be sending through empty arrays into Niagara, which is what we want, because we want Niagara to not fuck with it if it doesn't need to. So that did its thing. Pull all cohorts data. There's nothing. Calculate initial data. Nothing. How can you be... Oh, right. I'm just fucking dumb. You know how I'm stupid? And I just, like, unhook things and then get confused as to why things aren't working? You know? Do you remember that? Remember when I do that thing? So clear it, it's that. Pull cohorts, we got the things. Okay, yeah, I'm just fucking dumb in this. Hemisphere, step it forward, step it forward, step it forward. And then it just gets shitty. Calculate initial data. Okay, debug step forward simulation times 10. What is it doing? Update thing, no. Simulation times 10. It's then saying pull all cohorts data. Start new cycle. Go through update cells. Actor of class. Pull all cohorts data. In the atmosphere, dude. Pull all cohorts data, which will do this, which is then creating a new cohorts this frame, values this frame, mask this frame. On completion, sends it to Niagara and then clears it. So then what's going wrong here? Because now it just won't even clear the render target. It's just like fucked up. Let's just yeet the atmosphere debug drawer. It's like the array is too long and it's just getting shitty. You know? And now like the render targets are just in fuck zone. Do you know what I mean? But how and why would that be? Let's close and open again. I mean, maybe it's the texture budget shit, you know? Maybe it's just not happy. What's the texture budget command again? R dot texture streaming? R dot streaming dot pool size? Pool size 4,000. Okay. Atmosphere, initial data, debug drawer, initialize, clear it, that works. Pull all cohorts data, that works. Simulate. This should be doing something every half frame, or every half second. Or did I unhook that? Atmosphere, simulation cycles, event graph, update thing, calculate initial data, update thing, looping, go through, update all cells, pull the cohorts data. In our dude. Yeah. So why are we not getting any updating? Is it even, like, happening? Are you even doing this? That has all the oh god, they are big ass values. Fuck. Okay. Right. This is the area. The actual area, not the percentage of area. How do I... square root? Or divided by this... No, it should be square root, right? Win meters per second, get copies of it. Chuck them into here, index, yeah. Win cache this index, yep. That should be fine. So, is it just not able to write values that are out of bounds? Let's look at our win meters per second now. Okay, they're still like fucking gigantic values. Like huge ass values. Where am I going wrong? The current win meters per second stuff does get on cycle start. We set that to the cache, which, I mean, we can just see after it calculates initial. Yeah, they're all reasonable values. 12, 10, 6, whatever. I think what's going wrong is because the values go so high, it's like out of bounds of here, so it's just saying, yeah, like do fucking nothing. Because we're only doing adjacent cells. So how do I get the... So we're getting the area of each thing. Oh, it's the area... Square. It's just the area divided by this, right? Sorry, this divided by the thing. Then that gets multiplied. These... Oh, fuck off. Stop doing that. Go the other way, you shitload. That should be more reasonable. So we go play. We clear the win meters per second, which is normal values, and the win cache is now... Okay, that's all normal values. Play. Pull coords, data, blah, 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 blah. The win meters per second is now still reasonable values. Resume, back to here, clear the win meters per second, which is also reasonable again. Okay, so we can probably clear these breakpoints. Can't tell if anything's happening. What's the middle of our... Oh, we can just go length. Length divided by 2. Print string. After we do that, go to here. Chuck that in. Update thing. And tell us the middle value. Right, it is changing. I just don't know if the render target's updating. Let's say delta 10. Bam, big. Maybe 5. Alright, bigger values. Delta fucking 10, whatever. No, it's definitely not getting it all into the debug drawer. Why would that be? When we do initialize handler, is that why? Well, on begin play, set all the shit, blah blah blah. For the atmosphere debug drawer, that is all set. That's the guy. Begin play, initialize handler, sets all the things as the things. Right. When we do pull codes from data, is there like an editor? An editor boolean? In editor. Because, yeah, if this is doing this, then clearing them, and then the tick event gets called and does that, it's just going to have these ones. Then it's going to set the Niagara stuff, which are going to be empty arrays. Therefore, the thing isn't going to change. So, we need to... I guess when we pull all coords data, pull from coords, blah, blah, blah. We just don't want to call pull all coords data. That's from atmosphere itself. From here, we don't want to send to Niagara. We just want it to do that on tick. So we'll just see how that goes. Because, yeah, the values are changing. That's what I do know. Okay, so now they are actually updating. We're getting some wicked-ass shit happening. Why? What is going on here? Package distribution bool? I don't think that would help. Okay, where's this weird thing coming from? I feel like this weird diagonal is there because these values are going like the wrong way or something. Because I'm doing this weird diagonal starting thing. You know, let's just do atmosphere, initial data. Let's just make it giga noisy. Okay, so we still get the weird diagonal. So why is that happening, I wonder? Maybe I'll just do one. Pull data from coords. Do a. Okay. Here's an idea. Add an input. Pull data from coords. Editor. Oh, actually, no, I don't even have to fucking do it in the function. I can just do on data handler variable editor question mark, which is true by default. True by default on begin play. Turn it off. Right. Set it to false. So now, if we go into the debug drawer, and then we can say editor question mark, and then branch. Huge if true. And if not, we don't send it to Niagara, we just let it do its thing. So now if we go pull all coords data, the fucking piece of shit garbage. Is it just because this doesn't have initial data? Ah, there we go. Okay, so now we hit simulate. Then we can see weird thing. Why does this happen? And why in a diagonal? I think it's to do with the boundaries. And index to 2D index. Diagonal bugs are the best. Yeah. Well, okay, that's the initial data. On update cell, we have the index. Get the index, do the thing. We get the coords of that index. We look up, down, left, right, whatever. In here, wind meters per second. Update the cell. So that is just, yeah, the thingos. Is size, like, is it size -1? Is that why it's going into the fuck zone? X size, X dimension of the 2D array. I don't know. Let me just cache that. How much weather has been simulated so far? Heaps. The only thing I've been simulating is whether or not I want to die. Yeah, so is that the issue? I mean, that looks better, but not better. .1D index to 2D index. Maps a 1D array index to a 2D array index. Let me just get our little debug duper, boopy duper. When we say re, if our index is 0 and the dimension is 1, then what is our thing? Tell me the thing. New blueprint. Re. Okay, it's 0, 0. Makes sense. What about number 1? 0, 1. Excellent. Okay, so that should be like wrapping, kind of. Yeah, okay, so it doesn't have bounds. So, if this was 0, though... Well, no, let's just go dimension of 2. So, 0 should be 0, 0. Yep. 1 should be 1, 0. Yep. 2 should be 0, 1. Yes. And then 3 is 1, 1. This one down here. And then anything greater than that is... Okay, just, yeah, it just goes out. Out of bounds. But obviously we wouldn't be asking it, because it should all match up. If we do it the other way... Well, let me see when I'm doing the dimensions. So yeah, that is how many cells, including the 0th cell. In our manager. Resolution X, resolution Y. And yeah, no, it's a 40 by 40. I think what's happening with the diagonals is that... No, that doesn't make sense. The manager says it is a 40 by 40 grid resolution. Let's also just go to this debug material and not quantize it, because, I don't know. Fuck it. That shouldn't be... So why does it wrap diagonally? I know it. It's because, yeah, this resolution should be size 40. Index 0. Update cell. For each thing, array index 0. Do the thing. So yeah, I'm not sure why this diagonal happens. I think I know why there's things building up. And that might be because I've... Oops. Cocked around with the... I think I've cocked this up. Where we get the X. And then add in the X direction. So wind travel this step. This is all in a weird space. I mean, we could do this as a one-dimensional thing. So if we go to initial data, calculate initial data, and just do the X direction. And then we go atmosphere, calculate initial data, and then draw that to the thing. Then, yeah, so now we only have X values. So this whole thing, once it's simulated, should just move in. It should just go sideways. But I don't believe that's happening. Right? I can see it moving, but it's not. It's not thingin'. Is it? Which direction is it moving in, though? It should be only... Oh, let's make sure that it's only positive values as well. So we clamp it. Because, yeah, they're all going to push against each other and shit. Alright, now we hit simulate and... Can't fucking tell. Is it? I don't know. Let me just go back to the initials and make it bigger. You know, maybe I could just do a really dumb thing. Calculate initial data. Let's just do like a fucking select. Or sorry, a branch. Oh, I mean, I can do select. Select index to this. No, sorry, select bool. Or like select wildcard, boolean, into here is equal to integer is the integer. What's like the halfway point of 1600? 1600 divided by 2, 800. Or if it's like 800 or 840 or 841 or 801. Are they only going to be the ones on the edges? I'm not sure. Then we can say if that's thingo, then just make a fucking dude. Bam. If that's the thing, then move, then BX direction 50. 50. So now, if we calculate initial data and do this, we should have a render target with... Okay, they are just on the sides. So I need to add half of 40 to each of them. So 820, 860, 861, 821. That should give us a square-ish thing. Really stupid. Okay, we start with red dot. Hello, red dot. When I hit simulate, what are you going to do? Okay, you are moving in the X direction. And it is kind of spreading out. Now, is that in the X direction global space? It is, okay. So you are actually going in X direction. So in our atmosphere thinger, on update cell, with all this shit, and this shit, we do the things. I feel like something is incorrect here. I mean, if these were set to 100, and our delta was 1, in our initial values, let's say 100 in the X, in theory it should just move across an entire cell every thingo, right? But it isn't. It's creeping along. So something in our math has gone to the fuck zone. If our delta is 1, wind catch this index multiplied by the delta is the wind travel this step. So 100 units, should give us 100 units of travel. So the one in the X direction So this one here is the original Y plus the X value that it's moving in, which may or may not be positive or negative, but we know it's positive. So it's saying get the one to the other side. Cool, cool, cool. Do the thing, blah, 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 blah. So then this is our sideways stuff. So we are... with the original value, which is this one here. Right? Yep, down the bottom. Original index. We are pretty much saying what was the movement. So the current cell size, what was the total movement? Should be 100. So that's cell size 100 minus 100 is 0. Which means that that's 0 divided by blah, blah, blah. So then that should just be getting... oh, wait, that's for this. Yeah, no, 0. So get the current... get current wind meters per second, which should be 0 at our original index. And then set that down here. That should be 0. And then the one here, the sideways guy, is cell size, world space. Cell size, world space, 100, minus the direction in Y. Oh, wait, minus direction in Y. Where's my little graph? Yeah, minus direction in Y, which is 0. Wait, cell size minus 0. Yeah, it gives us 100. Multiplied by the distance in X, which is 100. So 100 times 100 gives us the total area. Should it be getting divided by the area of the square? Or should it be getting square rooted? Or should it be getting square rooted and then divided by the original length? Well, let's do the math. Let's say we moved it this way and there by, let's say this is 10 units, right? Calculator. So, oh, my back hurts. We have, let's say we're moved at 1 unit, right? 1 unit down, and it's a 10 by 10 thingo. So 10 times 10 is 100. 10 times 10 is 100. So, this part here would be 1 by 9, which is an area of 9. this butt here would be 1 by 1. This would be an area of 9. And then here we would have left... it's 9 by 9 now. 9 times 9. 81. And so to get that as a fraction, if I divide that by the length, 0.81. Okay, yeah, maybe it is just divided by the area divided by the length, not the square of the length. There we go. Okay, well now it's just going into shit zone. Oh, it says not applicable. So there are actually non-applicable zones. Now we're getting scared. Is that... what's happened here? It's like this fucking thing has gone out of bounds. Fuck you. We are still at it. I figured it out, though. Figured out what was kind of going wrong. To some extent. I just don't know why the render target is getting fucked. Debug RT. Eh? Bruh, come on. What have you done here? What is this? Hello? That is not a cleared render target. Debug clear render. What is happening? When I clear render target, I don't fucking know. I don't want to know. The fucking shit. Atmosphere. Initial data. When I... wait, hold on. Okay, no, we do clear all of them. Then do that. Then do the loop. Calculate all the shit. Right? So why does it not work after a certain, like... It's like this render target becomes corrupt, you know? Never stream. Size, blah, blah, blah. Let's just set the size to 10, and then it'll reinitialize when I unfuck it. Why is... okay, then do... okay, that shouldn't be 0. Like, you can't be 0. Calculate initial data. I know that it isn't 0. Okay, that... what the fuck? It's just... it's dead. Exactly. So, if I hit simulate, this should go to the side and do its thing. But then weird shit happens because of... out of bounds issues. You know? Okay, now it's just fucked again. Why? How even? How can that even... I just don't know how it gets so fucked. Because this is just saying, right? Debug atmosphere, RT, drawer. It gets from the data manager. Even on like the debug clear, right? debug clear render target. Grid array length, that -1. Gets the thing. Yeah. And then it should loop over all of that. And then do that, send them all to here. It's just like, what the fuck? How is it missing? Still makes no sense. It does not. It's just fucked. It's actually just fucked. I feel like a lot of it comes down to this function being really fucky. Because, like, yeah, it's saying that it's out of bounds or some shit at some point. Let me just save and exit this whole thing. Maybe I just need to write my own, you know, helper functions for doing the grid conversions, because the inbuilt one is just like giga fucked. Restarting Unreal's the biggest scope that we pray. Yeah, look, you're not wrong. It's just a whole thing. You know, one thing I might try is in here. When I initialize this, initialize handler, I should probably clear the render targets first. Clear render target 2D. It shouldn't really matter, but maybe that would just like refresh it so it doesn't get giga fucked after we set the size. How do you find the optimization aspect using render targets? I find them very performant. Yeah. Yeah, I use them a lot in PrismaticaDev plugin from what's it called? Niagara Grid or Niagara Grid 2D to do like all this kind of shit. And you know, I don't dip below my frame rate cap, even though I'm doing, you know, a wind simulation and a foliage simulation and a water simulation and a wind thing and, you know, all this complex horse shit. But it just fucking, like, it just does it. It's just really good. So, yeah, render targets are very cool. And you can do a lot of shit with them. Ooh, I'm a sneaky boy. I'm sneaking. Okay, no, I'm not. Shoo. Found to be a right pain. Are you using Niagara to do the writing to them? Or are you using the... what's it called? The draw canvas blueprint functions? Because the draw canvas stuff is like... it's essentially deprecated. Like, they've just ignored it for so long, and it just chugs super freaking hard. Bigger scope is a work in progress commit, so you have a less broken state to revert to before. Been there. Been there. Okay, so we go to our atmosphere thingo. What was the other option than draw to canvas again? Niagara Grid 2D, not Grid 3D. I mean, you could use Grid 3D if you need a three-dimensional render target, but yeah, Grid 2D is the POG way to do it. Let's do 6969. Yeah, Korean, we're simulating life and the entire world. No, not yet. Not yet, no. Unfortunately. I don't fucking know. Oh, the delta was... Oh, that's why it was going all fucky, because it was... The delta was set to 10 instead of 1. That's why I was going out of bounds and shit. New simulation cycle start. Copy all of that to there. Clear this one. Then resize it to the new... Wait, is that... Okay, any smart people. Any smart people. If I do resize... You know, I'm just gonna go set array element. And fucking... get last index. Just to make sure. Bam. We want to set this to that. Don't care. Size to fit. Let's just make sure. Something's getting real fucked up when we do shit. But... Okay, so. Atmosphere, calculate initial data, debug drawer, clear it, yep. Pull all cohorts data, yep. Why is that not our thingo? Where the fuck is the render target? Bruh. You're doing debug atmosphere render target. Sim data field UVs. You've got the new values. Where is it? That's not... That ain't it. Eh? Yeah, debug atmosphere, render target. Okay, maybe if I just hit simulate, it'll... Okay, that's something. That's, one of the things of all time. What the fuck? Is it the... When we're doing update cell, right? Is it actually this? Is that... Like, what the fuck is wrong with this thing? And the delta should be 1. Let's just check it here. So what's happening? What? What? How? Why is it? Huh? We're doing something wrong in here. I mean, it's probably not this. That's probably... Fuck that shit. Can I just, like, dock this in... Docking? No, let me put it in there. No, fuck you. Let me... Is there anywhere I can put this? No. You suck. You're shit. Alright, simulate. We do this, and it moves in that direction, but then why does it go... Why would it not... Do you know what I mean? Right, click on the tab. No, I can't dock it. I guess because it's an asset type. I don't know. Alright, something's going wrong. And I don't know why. But let's go to our initials. Let's just get... Oh, did I just do that one? Okay, so that's just one value anyway. Let's just do x100. No, you know what? Let's go x50. Oh, that's a big number. Let's go x69. That's my rapper name. Alright, we hit stimulate. We get the... Yeah, and then it should go... Okay, it goes to the side, but it just eats shit, basically. And it's duplicating itself into the layers below. So, like, clearly I'm... It should be just going sideways and... Oh, God, I don't know. This is all a fucking nightmare. Win meters per second, which gets done. So on initial, the manager grid array length. Is that last index or is it length? Maybe that's what's going wrong. And it's just like giga-fucking itself over time. Okay, that's worse. Okay. Okay. Hold on. I need to wee. All right. Let us go Bacchus. So, when we do our calculation, we update cell. We have the dimension of the grid, which is 40. I'm just going to fucking hard code that for now, just to really fucking make sure. Okay, cool. Cool, yeah, that's totally normal, I mean, it kind of is, but at the same time, is it? It's just feeding negative values and we're getting out of bounds shit. It's like the... Let me just double check something. On each update, give me the length of this. Is it just getting fucking smaller and smaller or some shit? No. Okay, so that's fine. But then what? It can't get the midway point. Let me just fucking get 825. Just check you. Or 800 and... What was it? 820. Is like the midpoint, right? Like, why are we getting NA values? Oh. Oh. I see. They're very big. They are very big. Well. Well, fuck. Okay, why are they so big? It's because we're doing something dumb down here. Let's go back to our stupid example. Oh, fuck off. Oh, no, it is... Okay, no. It is supposed to be divided by the square. I'm just fucking stupid. Or is it supposed to be all of them square root? Square rootin'? Now they're not doing an entire thing. You know? Atmosphere. Calculate initial data. Blah, 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 blah. For each dude, get the thing. If it is... I am doing all of them now. So all of them, blah, blah, blah. If that's 100 in X... They should be jumping a square every single time, and this thing should just move without bleeding. Now, why is it bleeding when we move 100 units out that way? When we update cell, we want to get the overlapping squareness that it's moved, right? So if this is 100, or this is 100 by 100, and we've moved it 10. So this here would be 10 times 90, 900. The remaining here would be 90 times 90, 8,100. This bit here would be 900. Oh, fuck. I think I know what's going wrong, or do I? So that 8 thingo, and then a 10 by 10 is 100. So that plus this plus this plus that, 10,000. So then if we divide that by, well, 100 times 100 is 100 times 100 is 10,000. So if we divide that by that, then that all equals 1. So if it was 8100 divided by 10,000, we get 0.81, meaning that 0.81 should remain in this square, and some other value should go there, and then some to here, and whatever. So now we just need to make sure that that is actually the case of what we are actually computing, doing all this stupid-ass math. So the absolute movement so the movement in X and Y combined gives us this one. Like, oh, we moved 10 units that way, cool, we moved 10 units that way, that gives us this area. If it moved more this way, but only a bit this way, then we'd get something like this, which is, yeah. So that's the area of the diagonal. We follow that to here. This then goes up to here, which is supposed to be the diagonal, which is supposed to be the original cell plus the other two dudes. Yeah, plus in the X and Y, depending on if they're... yeah, positive or negative. I should be able to just do that, but... There wouldn't be an issue here, right? No. Trust it. So then, for the diagonal, it is, yeah, both of them combined. For the uppity-downity, we are getting the added Y coordinate. And for the sidedy, we get the added X coordinate with the original Y. Okay. And then we get the current one as well, because YOLO. So, when cache this index, cool. So that should be getting up, down, left, right, diagonal. In theory. Sideways, up, down, diagonal. This one here should be sideways, which is the cell size 100. Cell size 100 minus the Y? Hold on. To get the X value, it is the length 100 minus the Y movement to give us this boundary here. And then multiplied by the X movement. So U multiplied by X movement gives us divided by, yeah, the sideways. Okay. And the up down is the cell size minus the X movement. So this way. Cell size 100 minus X movement would give us 90 multiplied by the Y movement. Multiplied by Y movement. Yeah. And then the diagonal is just the X and the Y. And then the original is the length. Subtract this, subtract that, multiplied together. Okay. Fuggles. Alright, so then this should work. Let me just go here. Compile, do your fucking shit, whatever. Let's just go resume, 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 resume. Let me just do this one. Right, index. One index. Oh, you know what it could be? Making it do dumb stuff is that sine can return 0. And if our y is 0, let's say our y is 0 and we're just moving in the other direction. This one here would be original x coordinate, but then the original y coordinate, which is just fucking writing it. No, but it should be 0. It should be adding 0 to that, so that should be fine. Maybe I'll just do like a thing. I'll just do a fucking branch for each of them, because fucking whatever. Just equals 0 and equals 0. So if this is so fucking sketch. If it does equal 0, then... So if x equals 0, if there is no x movement, then... If there is no x movement, then... fucking don't do anything. If there is no y movement, then don't do anything. If there is no x or y movement, then don't do the diagonal. And then always do the self. Maybe that's what's going wrong. I mean, it doesn't really make sense because it should be able to just set array element on the same index multiple times because these are all pure functions. I don't know, maybe it's just fucking itself. What the fuck? Cannot call... Hello? Cannot call Unreal Script render target text 2D. Data field, blah, 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 blah. Oh, while stopped at a breakpoint. Right. Because I was stopped at a breakpoint. That's so funny. Ha ha ha. Okay, why is this not fucking working? I mean, like, it's working, but it's not working. The original values should get set to 0. And that is a copy. Copy plus this new value thing. Smack that into there. And this should start empty. Because it's been cleared. Alright, let's just do a single cell here. Is that one or multiple things? Like, what the fuck? Calculate these nuts. Okay, that is a 1 by 1 thinger. It should be emptying itself. Because it's saying 100 units. So that's wind cache this index, which should be 100. This should be 100 in the X. So like 100 times... Okay, let me just do... What's our cell? If index equals 821, then print, no, fuck you, print, and then go straight into here, and then you go there, but then we're going to breakpoint you. Okay, so, step forward. The X dimension is 40. Our wind cache has heaps of values, but number 8, there it is, thingo, should have 100x0y, yep. So now the wind cache, this index is x100, wind travel is 100. So then over here, in the wind meters per second, this should all be empty, including 8, 2, 1. Stop fucking closing, you dog. Fuck off. 8, 2, 1 is empty. Very good. Okay, so here there is X. This is going 8 to 2. Item is 1. It's setting it as 1. Why not 100? Because then if it goes to here, it goes to there, it shouldn't do it. There, it shouldn't do it. And then here, it should be saying 99. So we're saying 99 here. Even though the distance, wind travel this step, should be, yeah, 100. Okay, so it's just that my math sucks balls. So why would my math suck so bad? It must be this, right? The wind cache this index is, yeah, it was 100. Where is my math sugma? Where the math sugma at? It's definitely this, right? But if I don't do that, then it gets giga-fucked. Like, if I do it like this, then it... Oh, okay, you can fuck off for a sec. Then it will do some fucking... It balloons out of control. How does area work? Has anyone ever worked with area? Let's just... We can look at all the nodes. Why don't I just fucking do that? Why am I such a spaz dick? Okay, so, dick spaz. No, that's with the fucking big-ass number. Swear about you. Area? Barely know her. It's funny. That's a really good one. Alright, index. The one over here, we get 1. And then... down here... Oh, fuck. Go back. No, fuck. Ask Chat... I don't think ChatGPT could solve this. Okay. So where are we getting 99 from? This is 0 plus 99. this bit here is 0.99, which is... I'm a fucking idiot. I'm fucking dumb. I'm dumb! Ah! Right. So cell size is in centimeters. And I'm just presuming that my fucking shit is a fucking... in, you know what I'm saying? Where else do I okay, fucking... I'm just a spasdick. They call me Spasdicator. Okay, no, stop doing that. Let me just... Okay. Wow, look at our wind simulation. Bro, that's so crazy. Oh my god, look at the wind. Why the fuck does that happen? Why... What? Okay, why do you go... It's not splitting. It just thinks it's... Huh? Why does it go... Oh, if it's out of bounds, does it return 0, maybe? And so then it's moving it back to 0. Let's do a little checker. Little checker. If the wind travel... No, why would it... This shit's dumb. Give me new blueprint with the re function. Okay, so if we have convert 2D to 1D, and our X size is, well, let's say 40. 40, why not? No, you know what, let's say it's 2. It's 2 by 2. Okay, so 0, 0 is... Can't see it. It's 0. Wow, who would have fucking thought? Okay, 1, 0 is... 1. Wow. 0, 1 should be 2. 0, 1... What the oh, I didn't compile it. That's 2. And then 0, 2... should be out of bounds, right? But it just says... It just says... 0, 0 is 0. Yeah, so it just says... that it's just fucked. 0, 1 is 1. Oh, and then 1, 1 should be 3, right? But then 1, 0.12 is like some number that's out of bounds. It shouldn't fucking be there. So what does this mean for us? Well, I don't fucking know. So we're gonna just get this x if this just equals 1, then let us know. If it equals a value, then print that bad boy out. Pardon me. And then that's just gonna reroute to there. You're gonna go there. You're gonna swoop yourself into there. You're gonna do that. We're gonna breakpoint there. And then we can check the coords every update. Okay, so we have our... That's the wind travel. It's 100. The coords are... Okay, that's not true. Oh, because that doesn't happen until later. So it hasn't actually been computed yet. Well, what if we said, fucking do this? That's the print thing. Dick Lord. Alright. Alright, print the string. What's the string? It's 2120. Cool. And then if I do it again, resume, now it should be 2220. And then keep going, keep going, keep going, keep going, keep going, keep going, keep going. 2920, blah, 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 blah. 3420. Right, 3820. 3920. 00. Why did you go back to 00? And now it's going to be at, yeah, 10, 20, 30. Which game is the best weather system, and why is it Terraria or Valheim? I disagree. I disagree. I think Vintage Story has the best weather system. Ooh. Okay, so why does it send its shit to the thing? Well, it's gonna be like, okay, what's our coordinate? Our coordinate was 40, 20, 20, then 40. So with a thing of 40, and it was like 39, 20. The Minecraft clone? Yeah. 100%. Vintage Story is like if Minecraft didn't suck ass. Where's my... Oh, there it is. Right, so that's... Okay, but then if I go to 40, compile... Okay, it returns 0 if the x is out of bounds. Okay, so... Okay. Okay, so we need to write our own grid unfucker that can deal with wrapping. with wrapping or border values. Because that's the thing, right? If this is a weather simulation and, you know, there's like, it's got a boundary, then, you know, we might want to say like, oh yeah, there's like fucking, you know, on this side, the wind does this. You know, here's some function to just send in values to, you know, these corners. Or we might want it to wrap around like an air tunnel. So I guess we just need to write our own functions for that, which we will do in the data field class. What do you think, old school RuneScape sailing still? Who did I watch? Maybe it was Solo Mission did a video about it. I thought it was pretty cool. I thought it was a nice, I don't know, it kind of like can bring a lot of stuff together. A lot of like disparate mechanics. But yeah, I didn't actually play the beta or the alpha or whatever it was. I haven't actually played RuneScape in like a year or more, maybe even longer. Maybe I should play RuneScape again. I wonder how much is a twisted bow worth? Twisted bow OSRS GE. $1.6 billion. Ooh, it's gone up. It's gone up. My investment's paying off. It was at 1.7 6 months ago. If it's to pick a favorite fish, what fish would it be and why? Do you mean in real life or in RuneScape? Real life fish. It's a good question. Dunno. Maybe maybe anglerfish, because they're just like spooky as hell. What's the dimension? What's the fucking length? Grid array length? No, it's the... It is... No, not dimension. Resolution. Resolution. That's stupid. Fucking dumb name. I mean, I should just promote that. All right, so the 1D to 2D should work. This should never have any issues. It's the 2D to 1D conversion that is kind of fucky. That's where the system is Noita, because yeah, actually Noita's pretty good. I mean, the only thing about Noita is that the weather doesn't really impact the base game. Or, you know, the non-meta game. Unless you count, like, the, you know, if you're in the mines and there's the water drains, if you count that as weather. Because it's like, yeah, you know, spills water out, it floods. If something uses electricity, then you pretty much die. Which is funny as. Right, now let's do coords to index. I'd like to make a game one day. I'm planning everything out. We'll probably use UE5. I want it to be proc gen, but the generation 2 I run across is water. You could have it as a simple Y level, so it's a plane, or you could do a voxel-based system like Minecraft, or damn it, like Terraria. Doesn't seem to be a good solution. What do you think? I would say, yeah, Kravia has a good point, where you can't do like what's like is Finland all below sea level? What? Cities are below sea level. Amsterdam, New Orleans, Venice. Well, no, Venice is... Oh, no, I don't fucking know. Anyway, heaps of places. Yeah, I'd say there's a solution between wineplay and full-on voxels. Also, the up and down is Z in Unreal Engine, so that's something to get used to. Vertical is Z-axis, and then the two horizontals are... Oh, why did my fucking... Did I just pull that up and down? No, I didn't. But yeah, you could definitely do some kind of, like, flood fill, where, like, yeah, you start at a point, and, you know, essentially just branch it out to whatever the world boundary is, and then, you know, you generate, like, a boundary where the ocean intersects with this, and you generate the ocean like that, which means that, like, yeah, this part here wouldn't get filled in with water, or if there was another bit in here that, you know, was going down, it wouldn't get filled in with water. Yeah, exactly. And, like, caves and stuff underground. So, yeah, you would just need to do... I mean, you could just do it, yeah, like a kind of render target thing. And just, yeah, like, flood fill from... I don't know. If you knew any point that was the ocean and just put it at 0, then you could, yeah, compare each pixel against the height map and stop it from going any further. And so, yeah, you would just flood fill all the boundary without anything inside needing to frick around with that too much. Vicinity rivers, lakes. Yeah, yeah. Which, for proc gen, I mean, it depends how you do the proc gen, right? Whether you just say, here's the terrain, now figure out where lakes would form, or you could do it the other way around, where it's like, okay, I want a lake to be here. I'm going to form the terrain around the lake to do a particular thing. Yeah. And then for rivers, again, you could kind of do the same thing where it's like, okay, I want a river to start up on this mountain and then go down. But the, yeah, you could do, yeah, like Krave is saying, you could essentially do a, just like an array of line traces to detect like a start point for rivers. Maybe over a certain height or something, and then it could just do a marching, you know, essentially like get the normal. Like starting here, get the normal, cross that normal with the up vector, and then cross the resulting vector with the original normal, and you'll then get the downward slope, and then you can just do another line trace, you know, in this direction, and just let that, you know, march along like this, and then pick every, you know, 100th, you know. Yeah, obviously you'd reach local minima quite easily. And that's presuming that you're not changing the landscape at all to accommodate for the river. So you could do rather than doing a line trace for one point, you could do an array of line traces or sphere traces, and get the average normal. So then you would get like the general slope of this mountain. You know, it would go down here. You know, even if we get to this point here where it's a local minima, it would be like, oh yeah, the average slope is going this way. And so it would continue going down and that kind of shit. And then from there, you could, because it would end up kind of quite straight, you could probably simulate river... Fuck, what's it called when rivers do that river shit? River curving time lapse. That's... Where's the one that... Real engineering. Rivers. Why rivers move? Practical engineering. That's it, not real engineering.
Mississippi River, drafted by legendary geologist.
Hey, I'm Grady.
It's part of
Meandering. Yeah.
Geological report he wrote in 1944 for the Army Corps of Engineers. But the maps he produced are anything but run-of-the-mill. Erosion occurring. Let's look at one more example of a natural disturbance to a river. Changes in the flow. After all, rivers rarely carry a constant volume of water.
He's like one of my favorite channels.
Seasons and
Such
the
a fucking
tremendous
nerd.
variability. That includes floods, where heavy precipitation within a watershed converges toward valleys to swell the rivers and streams. We can simulate a flood in our model channel just by turning up the flow. And hopefully at least this parameter matches your intuitions. You can easily see the sediment being carried downstream by the increased flow of water. The banks of the river erode and the material is carried away by the flood. Looking at our diagram, it's easy to see why. For freight traffic and fill up reservoirs reducing their. But look closely and you'll still see sediment moving. It erodes from the outside of bends where flow is most swift, called cut banks, and it deposits on the inside of bends where flow is slower, called There are also factors that it doesn't consider, like vegetation or pulsed flow. For example, imagine a scenario where the climate shifts toward more extreme periods of droughts and floods. Lane's relationship looks at averages.
Yeah.
So
good.
one river has a relatively constant flow, while an identical river has
So good.
of high and low flows.
Just look
as
up
long as
Practical Engineering on YouTube. It's a big channel, 5 million subscribers. But he's got so many fucking lit videos about, like, infrastructure. But a lot of it is like, like fluid dynamics. In a practical sense. And I know all about pre-stressed concrete. Yeah, true. And like rebar reinforced concrete and shit. Water pressure over a dam is proportional to its length. Exactly. Simulating river ships on top of a high fidelity fiddly to be worth it in game. Faking it with 4 to 5 splines is easier. So yeah. Well, you probably wouldn't want to simulate it in real time. You could probably write something that, can run it pre-computed. Because we're talking about procedural, procedurally placing a river. So like where would a river form? Or if I tried to form a river at this point, where would it do its thing? Lines for your traders to find the slopes and then use the point to make splines out of it. Yeah, exactly, Mars. And then you could take that initial spline, which would usually end up being very straight, and then you could wiggle it. You could push it out so it like does S-bends and whatever, based on some kind of, groundwater saturation level, soil strength. Yeah, I mean, yeah, you'd need to have a bunch of data layers, to like do stuff like that. And then once you've got those rivers, traced out. Oh, and obviously, like, they'd all conjoin at some point. Because, like, from this mountain, if it rains on the mountain, it's not like water is just going to flow directly from here. It's like the water will gradually, come out of the soil or run off the soil and turn into streams, which then all converge together and turn into a creek, which then more of them come together and turns into a big river. But the thing that something funny that I could easily do with this weather sim, once I fucking got it happening, is when there is precipitation, because we have the terrain data. Oh, that's going to have to do its thing real quick. We can then actually do water runoff simulated. And then, based on the water runoff, multiplier or level, we can move the level of the rivers up and down so that, if you're like trekking across this mountain, the first time you do it, maybe the river isn't flowing and you can just get across. And then maybe you go and pick up some armor and you're on your way back and you're wearing this heavy armor and it's just rained. And it's like, this river is fucking flowing super hard and you can't cross. Or you have to find some other way to cross. Or you have to, like, cut down a tree and somehow move, You know what I mean? Gameplay. Or you could try and just run through the river, but then you'd get swept up and probably, die. Which could also be funny. But yeah, so here's the normal data of our thingo, which we could use to run off water. The rivers act like they're too much of a pattern that makes the player recognize it too fast. You mean like doing runoff and whatnot? Like you know, when it rains, the rivers get... I think it's more like situational. And I think once players like put it together in their head, they're like, oh my god, it just rained. You know, it's going to be half a day until this river stops going so fast. You know, maybe I should cook some food instead and wait for it to die down. And yeah, it very much depends on the terrain. So if you were exploring somewhere that you hadn't explored before, and it was like really mountainous, and it was raining, then you could, you know, you could assume that you're gonna have to cross a river at some point. So maybe you would pack lighter, or, you know, not wear encumbering stuff. So using PCG compute shaders for spline. Apply the least resistance, link landscape deforms to the spline, find bounds of spline, apply RT simulation, then bake RT. Yeah, true. You can even use RVTs to do the flow maps if you needed it higher resolution. I was also thinking, so because RVTs are just so easy to draw to, and now that we can sample RVTs in Niagara, and then in Niagara draw to render targets, I might write a little... I don't even know what it would be. It would literally just be an actor that can, like, offload an RVT to a static render target for, like, you know, data stuff that doesn't need to be updated. So, like, you know, I've got these flow maps here, which is just saying, oh yeah, here's the flow of the river, and they can all blend together, and then that gets read in a flow map. So it's like, oh yeah, this part here is stationary, but this part is flowing, and, you know, there's like a whirlpool here doing whirlpool shit, and like it all blends together. You know, you can see like the flow direction and whatever. And like, technically this doesn't need to be on an RVT if it was low res enough. The benefit of it being done on an RVT is that it works over the entire frickin' world. Which for something like, you know, this shoreline wave generator thing, where like here's the shoreline and the waves do this, you'd probably want to see that from like very far away and whatnot. And if you would, and it kind of needs to be decently high res, but I don't know. It's but I guess the shader cost of just sampling a render target is like so much better. And you could even combine the channels in different ways. So yeah, I don't know. I think offloading stuff to just a big-ass render target makes sense. Because what? It's like fucking 200-something instructions to sample an RVT in a shader. Which is dumb. So yeah, I don't know. RVTs are runtime virtual textures. So it's essentially like a render target, but it's, you know, infinitely big, and it's like made up of tiles. So I'm using one here to kind of send data into this water shader so that it knows where, like, the shoreline of an island is. And then it can just, you know, go from there and do its thing. Or in the case of this here, you know, there's some river splines, and those river splines are drawing their flow direction to an RVT, and then that RVT gets read by the water shader to determine the flow, you know, the flow map strength. And so that's why we get this, you know, it's like flowing here, and then it fades and isn't flowing here. And also where it knows to, like, put, you know, this shit. We're releasing plugin? Not yet, Dylan. I might include this in the next update that just... there's a few things I want to fix. There's also some other stuff that I just need to, like, finish. But I just got a bit brain dead from working out this particle shit. Not physical water, just a texture. Kind of. So, I mean, all water in any game, unless it's using an actual fluid simulation, which is, you know, not really doable on this scale. This is just a texture. Or, like, you know, it's just a fake... you know, we're just doing... We're just deforming a mesh based on some pre-computed math, right? So, like, if I go into the ocean shader... and I go to this value here, which is the time value. Oops, I meant to do this. There we go. So, ignoring the foam, because that's supposed to... Oh, maybe I could... Does my flow map function have a time override? I don't think it does. Where the fuck are you? No, it doesn't. Doesn't matter. So yeah, this thing here, this big code jumble here, which has 16 of these things in it. So there's a lot of math going on, but it's just saying at a given time, what, you know, should this look like? And so, you know, yeah, you can see it, you know, doing its thing. The way we do a buoyancy simulation is that because this is all deterministic, so I can say, 20 seconds in, the waves are going to look like this. And so on the CPU side, I can be like, okay, let's run this same math for a given location and get the height that we would, that, you know, or you know, the difference in height from this point here, where the actual geometry is, you know, and it would be like, oh, the water is actually 50 units lower, and so then in, you know, our buoyancy component or whatever, it would be like, okay, don't apply any buoyancy because your character is actually above the, wave. Or if we were down lower, it would be like, oh yeah, you're this far below where the wave visually is. So that's how most games deal with buoyancy, is by using a deterministic, you know, function to make their waves look however, and then on the CPU, you can just repeat that same calculation, but for a single point rather than every point, and then figure out the offset in that position. It's getting cold in here. I might put a cardigan on. BRB. I'm back. I'm back and I'm warm. Ugh. Hood up or hood down? Hood up or hood down? We could, like, go goblin mode. Hold on. Oh, fuck. Hell yeah, let's go. Oh. Fuck yeah. Cozy mode activated. Hell fucking yeah. Haha, Boolean is cozy. True. Alright, let's see. Is it more expensive to do flow as simulated runoff like you suggested, or instead have rivers flow from grid point to grid point? Do you mean in terms of if you're doing procedural stuff? I would do... So like a spline, right? So you could simulate or like do the kind of runoff, you know, line traces, point by point kind of thing. You'd end up with like, you know, hundreds of points. But then you could simplify those points into a spline, which is just, you know, a few points. But it kind of figures out all the in-between shit. So you could just like, you know, do your rivers like that. But they'd be first guided by, you know, some kind of algorithm. So that would probably be the better way to do it, where you actually generate, you know, a mesh that looks like a river. And, yeah. How do you think your flow maps in Ocean would work with generating levels at runtime procedure? The Ocean looks great and looking forward to filling it work. Thank you. The Ocean is just a... They're just planes. They're just meshes, so you could put them anywhere as long as you kind of figured out where the ocean should be. As for the shader, it just does its own thing based on things. I don't know. Where's the ocean manager? So yeah, the ocean is just... It's just an effect, really. And then, yeah, you can tell it to be, like, calm. Or you can tell it to be, like, giga-fucked. Probably not that far. I think this is the maximum. Hello? Are we back? Why is my chat... What the